it smaller, move it out of the way. This is chapter 2, operators and statements. And as before, we've seen most of this already. Here's an example. First off, we got int y is equal to 4, and then our semicolon, and then double x equals. Now, here we have 3 plus 2 times, and there's a negative here. So what this would do is it would first decrement y by 1. So the 4 would go to 3. And then it would do 2 times 3, which is 6, plus 3 would give us 9. Now, if you put the minus after it, then it lowers y by 1 after it does it. So let's see, is that a true statement? I don't know. Let me try. I don't really use those, so. New class. Double x equals 3 plus 2 times that, and system dot out dot print line x, then run it. Okay, so we get our 9 like we indicated. Let's put that there and see if we get 9 again. I don't know the order of precedence that it does on that. Gives us 11. So it goes ahead and first does 4 times 2, plugs the 4 in for the y. 4 times 2 is 8, adds the 3, gives us 11. And then it decrements it. Like if I were to print out the value of y here, I would see it's going to give me 3. I try to keep my programming fairly simple in that regard. I don't try to combine 2 things on one line. I'll do it on the next line. I think it's better programming practice to do that. Like if I'm going to decrement y, then I'll say y is equal to y minus 1 here. Or you could just simply say y minus minus. But that's a matter of, I guess, programming style, what you want to do. And what you're talking about there is order of operations. By decreasing order of operator precedence, if 2 operators have the same level of precedence, then Java guarantees left to right evaluation. You need to know only those operators in bold for the OCA exam. so the exclamation, the asterisk, the divide, the modulus, that returns a remainder, plus and minus, addition and subtraction. The relational operators, less than, greater than, less than, equal to, greater than, equal to. The equal to, not equal to. The logical operators. And short circuit logical operators. And then it looks like, I think this is in bold, the ternary operators. Talk about the arithmetic operators. You got all your standard ones, addition, subtraction, multiplication, modulus, and so forth. By default, when it runs across a line like this, it does the sort of operations first. You remember that from algebra. In algebra, you had, please excuse my dear Aunt Sally. So it does multiplication and division first. So it does 2 times 5, which is 10, and does 3 times 4, which is 12. And then goes back and does the addition and subtraction. But if you have parentheses, again, it does what's inside parentheses first. So this would be 5 plus 3 is 8. And still doing what's inside the parentheses. So we got 8 times 4 is 32. Minus 8 is 24, I think. Times 2 is 48. Assuming I can do my math this morning. Yeah, 2 times 24 is 48. From a programming point, if I really don't know which one has precedence, I just put parentheses on it. It's not worth even looking up. It's just so easy to put parentheses around what you want done first. Now here's division. 9 divided by 3 gives you 3. Now if you got the modulus operator, this returns a remainder. So this is old school division. So for example, if I have 9, I'm divided by 2. Well, 2 goes on 9 4 times. 4 times 2 is 8. Then we subtract that. We get 1. So in terms of integer division, 9 divided by 2 will give us 4. 9 modulus 2 will give us our remainder, which is 1. This is good, useful in mathematical applications, and probably not much else I think of. Remainder. Integer division, obviously. Determine if something's even, odd, or even or odd. Because if you divide by 2, if the remainder is 0, that means it's even. If your remainder is 1, that means it's odd. Let me give you examples here. 10 divided by 3 is 3 with remainder of 1. 11 by 3 is 3 with remainder of 2. 12 divided by 3 is 4 with remainder of 0. So if I do 5 divided by 3, see we get 1. Now notice those are both integers. If I change one of them, I put a 0.0 on it. That makes it a double float. And so when I run it, since one of them is a double, it's going to do our regular division with decimals. Now, now that you understand the basics of operators, it's vital to talk about primitive numeric promotion, as Java may do things that seem unusual to you at first. If you call in chapter 1, Java building blocks, where we listed the primitive numeric types, each primitive has a bit length. You don't need to know the exact size of these types for the exam, but you should know which are bigger than others. For example, you should know that a long takes up more space than an int, which in turn takes up more space than a short, and so on. You should memorize certain rules Java will follow when applying operators to data types. Numeric promotion rules. If two values have different data types, Java will automatically promote one of the values to the larger of the two data types. If one of the values is integral and the other is floating point, Java will automatically promote the integral value to the floating point value's data type. This right here, when I threw a decimal on here, it did not take that backwards and say, okay, that's an integer, even though it technically is at the 0.0. It went to the next higher level. So it said it's a floating point. Smaller data types, namely byte, short, and character, are first promoted to int anytime they're used with the Java binary arithmetic operator, even if neither of these operands is int. That's interesting. With Java binary arithmetic operator. Okay, so I'm doing a plus b here. That should give us 2. Then C gives us 2. Question becomes, how do you find the type? I expect it's type, but sometimes it's something else. Get class, get instance, get class. And I've got something right about it. Done like that. Web educator. It's more complicated than I wanted. Looking for one simple command, not like a whole program. Not that it matters, I guess. Get class. See, it doesn't appear to work on primitives. Oh well, I'll just trust them. What they're saying is if I put in the a plus b, that it's automatically going to be promoted to an integer. So we'll not want to be byte. After all promotions occurred and operands have the same data type, the resulting value will have the same data type as its promoted operands. Last three rules are the ones that most people have trouble with and ones likely to trip you up on an exam. For the third rule, note that unary operators are excluded from this rule. For example, applying plus plus to a short results in a short value. So if these are both byte, so there, sum is equal to a. Sum's a byte, a is a byte. But if I put the operator in here, a plus b, this a plus b, these are both promoted to an integer. and then I'm trying to assign it back to a byte. Short is smaller than integer. What am I doing? Long. There we go. So it's got to be one, if not the same data type, then one higher. So you can't go one lower. What is the data type of x times y? Well, x is an integer, y is a long, and long has more precision to it. Bigger numbers can go into it. So x times y would be long. X plus y. Let's see. This is a double. Float is 2.1. I think double has more precision, allows a bigger number. So x times y here, or x plus y here, would be a double. Maybe. Oh, this code will not compile. Why not? As we recall from the floating, is consumed to be double unless postfixed with an F, as in 2. Oh. If you type this in, the line that has float won't work. That's what they're indicating. I should know that from C# with Unity. You have to put an F here to get it to work. Because by default, it assumes this is a double. If you just have 2.1, and you're trying to assign a double to a float, which is a less precision, so it would be given an error. But then you can do x plus y. Let's see, what would be the data type of x divided by y? They're both shorts. Let's say a short, but let's see. Oh no, that's right. They're all automatically promoted to integer. Can't remember what I just said 5 minutes ago. Okay. What is data type of x times y divided by z? Float, double. Okay, so doubles are highest precision. X times y. I would tend to think of double, since doubles are highest precision. But float, I wonder if this would work without an F. Yeah, it does work without an F. Why does it work without an F, do you think? What is 13? It's an integer, isn't it? And so we're promoting it. It's going from an integer to a float. Where if we had 13.1, 13.1 is a double, and we're taking something at a higher precision and trying to throw it back to a lower precision. And that's where you have to have your F. Okay, x will automatically be promoted to an integer. Okay, short. Okay, so yeah, it is a double value in the end. Now our unary operators. By definition, unary operator is one that requires exactly one operand variable to function. We've seen that before, plus plus. That's popular in for loops. It's interesting. I don't think I ever tried that. Indicates a number is positive, though numbers are assumed to be positive unless it's accompanied by a negative. All the rest of these I've seen, but I've never seen a plus. Indicates a number's positive. It doesn't work for me though. So this is false to begin with. Comes down here. The exclamation just flips it to the opposite meaning. So false goes to true. The negation operator, the negative flips sign. That's what you'd expect. Cannot apply a negation operator to a Boolean, nor can you apply a logical complement to a numeric expression. Beware of questions on exam and try to do this, as they cause the code to fail to comply. For example, none of the following lines of code will compile. You can't have the opposite of 5. I know in logic we think not 5, but that doesn't make any sense in programming. You can't put a negative before a Boolean. So I am wondering if some languages would allow you to do that. I don't know if that's true or not, but not Java. Yeah, see, for Boolean, you have to actually use true. You can't use 1. Even though Boolean, we think of true or false, 1 or 0, and some languages allow you to put numbers in there. Java doesn't. And the exclamation 0 doesn't compile. Here you can do a plus plus. What this does is it adds 1 to it before it prints it. On the other hand, if you put the plus plus at the end, it'll print the old value counter and then increase it by 1. Same thing here, minus minus, that'll decrease it after it prints. So it'll print the old value of counter, which is 1, and then decrease it, and then that'll give you 0. Sometimes it doesn't matter whether you put it before or after. For example, system dot out, or not there, num plus plus System.out.println num versus if I set equal to 1 and I do num or plus plus num. System.out.println num. It doesn't like something. Pinned int. Pinned. Why does it keep changing that on me? I don't think I'm choosing that. There. You can see both and give me 2. Since it's the only one on the line, doesn't matter whether you increase it at the beginning or end, it still just gives you the same value. Oh, yuck. What's this one doing? X is 3. The what? No. Yeah, this is going to be interesting. I have to think about this one. Now, that's not say I'll even get it right, but 3. Okay, so plus plus increases it beforehand. So that'll be a 4. Now just increase x to 4. That's 5. Bring everything else down. Plus minus minus x. Okay, so I think this would be the old value of 4. But then I'll decrease it after we get down to the line. And back to 3, I think. I'm probably not even close. 20 divided by 4 plus 3. Best guess for me is I think it's going to give us 8. Let's say it's probably not right. Code is 2. Not even close, I guess. Let's see. So how do we read this code? First, the x is incremented and returned to the expression, which is multiplied by 5. Okay, so it does that before it starts changing the rest of these. So that gives you 20. Next x is decremented. The original value of 4 is used in the expression. Oh, so it doesn't actually change the value. That seems strange. Sure enough, too. I didn't believe him, but I've seen is believing, I guess. Because this, normally when you do a plus plus, it changes the value of x. Changes the value of x, then that should be a 4. Then if it went ahead and did the 20, that. And I would guess this is still, since the minus minus occurs after, so I think that'd still be a 4. But since if order operations wise, I went ahead and did that, then it now decreases that. X is now 3 again. 20 divided by 4 is 5 plus minus minus x. Minus minus should reduce that beforehand to. Boy, I'm not even close. Wait a minute, what? I'm looking at the wrong one. Y is 7. Okay. I don't know what I got the first time, but okay, I see where that's coming from. Would you ever do this in real life? If you did, somebody would curse you. No programmer in their right mind does that. Although, interesting enough, this is the type of code that one time they had me go look at an engineer's code. He'd written in Perl. He was working on a project. Some of you have heard this story. And I will go out there, and his code looks exactly like this. And the idea was I was supposed to fix the problem with his code, so he'd have time to work on the priority project he was on. He didn't have time to look at the fix his code. So I'm sitting at his desk, and I'm after about 2 hours. I think he told me to go back. I don't remember exactly, but it was obvious I wasn't going anywhere on it because he had written all of his code like this. It was unreadable. You'd have to be a genius of some sort to go through the code and understand it all. You like what I just did, where I'm trying to break it down step by step. Interesting. Got your assignment operators. Casting refers to changing something to a different data type. Converting. Here, this is a double, and I'm trying to assign it to an integer. It can't go up like that. I don't know why this compiles. I expect that's too big of a number for short. Short is an integer, but must not hate take numbers that big. 9f. F is floating point, which is a higher precision than integers. You can't assign that back. And I'm assuming that's too big of a number for long. Final large interprets literal as an integer. Oh. So Java isn't smart enough to recognize that this it could be a long. Um, it automatically assumes since it's a number with no decimals, it's an integer, is what they're saying. And you have to put that capital L on the end to get it to work. Here's how you cast. You put beginning parentheses and then your data type and then closing parentheses in front of it. And there's some things you can't cast. Now this right here is going to work fine. But you can't cast this. Doesn't make any sense to convert a string to an integer. Although we've seen already that we got methods that have been defined to allow us to do that. But just with the work of the data types right here, you can't do that. So system.out printf %d and %d. Let's see what that gives us. So the question becomes, and I don't know the answer to this myself, does it round or does it just truncate? If it rounds, the first one should be out 3 and the second one should be 4. If it truncates, they both should be 3. These are things you want to explore if you're doing that kind of conversion to make sure it's going to handle it like you want. 3 and 3. So it truncates. So if you're trying to change something to the nearest integer, this would not be how you'd want to do it. Now, if you want to truncate it, then this is how you'd want to do it. And there's some kind of math function for that. I don't remember what it is exactly. It's either floor or ceiling, I think. Returns the largest, closest to positive infinity, double value that is less than or equal to the argument, and is equal to. No, that kind of sounds like the truncate. How about ceiling? Might be neither one of those. Because that probably returns a greater. Well, I expect you just do a round. That'll return, I think, a floating point, though. See if that's right. Yeah. Assuming it's not capital R. So we're possible problem from long to integer. Math.round returns a long. So let's put an int on there. And run it. And it gives us 4. So int wouldn't necessarily handle it like we'd want in a program. Might want to do something like this. So this is converting 1.0 to an integer. So we already seen that truncates, though this doesn't have any real meaningful decimals. So I give us 1. And this would Java short range of values. Short has a maximum value 32,767. So why would it be stored as 20,678? I understand this is an integer, assuming that's big, not too big for an integer. Should be fine. Then a short converts it to a different data type. Strange. Maybe we'll talk about it. Previous example, not compile those costs. The second value, 1,921,000. Okay, that's the one we're talking about. Is too large to be stored as a short. So numerical overflow occurs and it becomes 20,678. Overflow is when a number is so large it will no longer fit within the data type. So system wraps around to the next lowest value and counts up from there. I don't even think I follow that. What in the world that's trying to say? Okay, this is beyond the scope of the exam, but something to be careful. And here's another issue. We got a number here that's an integer because it's number, no decimals, and we're adding 1 to it. This is the maximum int value. Adding a strictly positive value, so we'll cause it to wrap to the next negative number. Important part on that is just know what your range of values is you're working with. If you're going to be working with huge numbers like that, then you got to make sure you choose the appropriate data value. This right over here, 1,921,222 is not too big if we're talking about dollars. Coke Industries make billions of dollars a year. If I tried to use an integer for it or short, then it'll cause me problems. Okay, let's see what's wrong with this. X is 10, Y is 3. It promotes those to integers, makes that 30, but then tries to take it back to a short. And I think what we'd want, we'll read it here in a second. Is that right there? $30. This right here is an integer. And so I think this is an integer here, but then it's able to take it back to a short, which is a smaller integer, which would be fine since it is a smaller integer. But I didn't think it could go back that way. But obviously I was wrong. Now here, another integer can take back there, but then x times y should promote both those to integers. And so you can't assign that back to a short. If that's an integer and I can't assign it back to a short, how come I can assign these back to a short? Maybe 10 isn't what I think. Remember, short values are automatically promoted when applying any arithmetic to the result value being a type integer. Okay, so I'm guessing that it thinks this is a short based upon that logic. And then that's how you do that. Compound assignment operators. Only two of the compound operators listed required for the exam, plus equals and minus equals. I don't really like those, but they're there. That's equivalent to like x equals x plus 1. You can do x plus equals 1. And that's a shortened version of that. They're just glorified forms of simple assignment operator built in arithmetic or logic operation applies left and right hand sides of the statement. And you see this here, x equals x times z. And here we got x times equals z. That does the same thing. Okay, yeah. Y is an integer. So here we got an integer. Here we got a long. And so to promote them both to a long, this should be a long to do that. Or do a casting, int. See, last line should be fixed with an explicit cast to integer, but there's a better way to use a compound assignment operator. Okay, long. This is an integer. We'll first cast y to a long. So I guess x is. That's interesting. perfectly valid, if not a little odd looking. Not sure why you'd ever do that, but see, I would have wagered money that y would be equal to 1. Since it's got an assignment in here of x equals 3, I would assume it would have returned a Boolean of like 1, indicating true, and then this would have promoted it to a long, and so y would have been 1, but obviously I'd be wrong. Key here is x equals 3 does two things. First, it sets the value of the variable x to be a 3. Second, it returns a value of the assignment, which is also 3. Exam creators are fond of inserting the assignment operator equals in the middle of an expression, using the value of the assignment as part of a more complex expression. Okay, relational operators, less than equal to, greater than equal to. X and y. 10 is less than 20, so that's true. 10 is less than or equal to 20, so that's true. X is greater than or equal to z. X is 10, that's true. X is greater than z, which is false because 10 is not greater than 10. Fifth, relational operators apply to object references and classes or interfaces. A, an instance of B. True if the reference that points to it is that A points to is an instance of a class, subclass, or a class that implements a particular interface, as named in B. It's out of the scope for the exam. Logical operators. We got the and here. If x is true, y is true, then that's true. If x is true, y is false, then this is false. If x is true or x is false, y is true, it's false. And right here, if x is false and y is false, then that's false. So the gist of that is when you got the and, the only time it's true is when both of them are true, which is the way it is in real life. I'm gonna go eat if I'm hungry and I have money. Both those have to be true for that to be true. I can't go eat if I don't get any money. If I'm not hungry, then I want to go eat. So both those have to be true. Now this is the or, the pipe symbol, and in this case, you look at all these that are true, and they occur when at least one of them is true. So if I'm gonna pick something that's red or blue, well, it could be red, I pick it, or if it's blue, I could pick it. So either one, or they both could be true. Now here's an exclusive or. And the gist of it, the exclusive or is summarized right here. The exclusive or is only true if the operands are different. And then they present the conditional operators, the two ampersands or two pipe symbols, which are referred to as the short circuit operators. They're pretty much identical to the single ones, except that the right-hand side of the expression may never be evaluated. The final result can be determined by the left-hand side of the expression. For example, if 3 is less than 2 and happy is greater than 5. For this to be true, they both have to be true. Right away, we know 3 is not less than 2, so this is false. So the question is, does he even need to check this? And that's what this is referring to, is if both of these have to be true and this one's false, there's no need to even check that one. You see this, some mathematical, though there's oftentimes better ways of doing this. int num1 is equal to 5. int num2 is equal to 0. System.out print line num1 divided by num2. My code open before freezing. Okay, got an error. What's my error? Division by 0, or arithmetic exception by 0. Okay, well, I got an issue there. Now I can say if num2 is not equal to 0, now this should not do the division. And it doesn't. Now let's say I wanted to make this a little bit more complex. I wanted two conditions on there. Num is not equal to 0, and num1 divided by num2 is not equal to 5. Now I might need some parentheses in there on there because I'm not sure of the order of operations. So I'm going to go ahead and put it. Let's run that. We got an error. Division by 0 again. And I don't see why I'm checking it here, but it's going ahead and doing this over here. Well, what I want to do here is I could rework this such that I put an X or another ampersand here, and then it checks to see if this is true first. If this is true, then it'll do this. So let's run this. And if my thought process is right, it shouldn't blow up. No, it didn't. Didn't do anything, which it shouldn't. Does that make sense on what that's doing? No, I really don't like that. I don't program like that. I say if num2 is not equal to 0, then I'll put the if statement on step 1 here. I'll say if num1 divided by num2 is not equal to 5, then I'll do my system.out, print line, whatever, like that. So this accomplishes the same thing as the 2 ampersands. I always figure in programming, the more complex you make it, the harder it'll be for yourself to understand it 2 years from now, and also the harder it'll be for a programmer coming after you to understand what in the world you're doing. But that's short circuit operators. Oh, what's this doing? Let's see. X equal true. So I think this will return true, or and if one of them's true, then it doesn't even check the other one. So it won't even evaluate this right here. Because it doesn't matter what you put in for Y. The or says that if one of them is true, the entire thing's true. So again, short circuit operators. And you see those in most programming languages. Well, I shouldn't say that. Most of your higher level programming languages, you see that in. If X is not null, then we want to go and get the get value and check to see if it's less than 5. Again, you could accomplish the same thing by having two if statements, like I have right here. But that's a short circuit. Equality operators. Determine equality in Java can be a non-trivial endeavor, as there's a semantic difference between two objects the same, two objects are equivalent. Okay. Here you can compare two numeric primitive types. The numeric values of different data types, so values are automatically promoted, as previously described. For example, 5 equals 5.00 returns true since the left side is promoted to a double. So it promotes this to the higher level of precision. You can compare two Boolean values and compare two objects, including null and string values. Assuming this would return you can't assign can't check a Boolean against an integer or a short or whatever that's. Let's see, let's talk about that. Does not compile. I think that's the reason on that. Here you cannot check a Boolean against a string. And here you cannot check an integer or short or whatever that is against a string. Y is equal to false. Y is true. X would be true. Output is true. Okay, that makes sense. Because remember, this reassigns the value to true, which then gets assigned to x. For object comparison, the equality operator is applied to the reference to the objects, not to objects they point to. Two references are equal if and only if they point to the same object or both point to null. Let's take a look at some examples. I wonder why that doesn't give you an error. Not sure if it'll let me copy it in, but let's see. I understand true and false down below. Of course, I don't know what the import is. Import java.io. File. I understand the X and Y wouldn't be equal. I'm not sure why it allows you to create a new one with the same name. Oh well. Not that you'd ever do that. Understand Java statements. Only got about 4 minutes left, so that's probably not a bad place to stop for today. So we'll go ahead and stop there and then continue on Thursday. Is there any questions on any of that?